the infrastructure of this GAE is based on, or it's going to have a service, is going to provide automatic scaling and high availability. This app engine utilizes both front-end services like App Engine front-end for load balancing and static content servicing to indicate the Microsoft Azure network, and it has so many different components here. It built upon infrastructure layer. This layer consists of SQL Server clusters and management services that oversees them. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Student, let us start our discussion with the concept cloud computing platform or cloud platform in industries. So, in this session, we are going to talk about Google App Engine, Microsoft Azure, and SQL Azure are the services or service provider with respect to cloud computing in industry. Now, let us start with Google App Engine, that is GAE. So, what is GAE? It is a fully managed serverless platform as a service, that is PaaS service, that allow the developers to build and host scalable web applications on the Google's infrastructure without managing servers. And its architecture is designed for automatic scaling and high availability. So this is one of the service provider, that is Google App Engine. So what exactly it is? It's a service from the Google, and it is a fully managed service. If I say fully managed service, it is nothing but is going to automate the many of the services with respect to administration, and serverless platform as a service, that is PaaS. You know what the definition of PaaS? So here, if platform as a service, it means that the service provider or is going to provide a software developer with different tools for developing different types of software or to build its own software, and it is a scalable web application. So that is the meaning of platform as a service. So it's going to provide a platform for the users, different types of platform as per the user requirement, and it also going to provide the infrastructure without managing servers, and its architecture is designed for automatic scaling and high availability. So the infrastructure of this GAE is based on, or it's going to have a service, is going to provide automatic scaling and high availability. What is automatic scaling? As we have seen in our previous session, so here whenever any services can be scaled up or it can be scaled down as per the user's requirement. And what is the meaning of high availability? It is nothing but fault tolerance. So it's going to provide a continuous, seamless services to the customer or to the users without any interruption. So that is the meaning of high availability, and or in other words, we can say that so these services are available to the user at any point of time. So that is a high availability service. In the next slide, we will see this is a schematic diagram to indicate or to represent Google App Engine. And here, these are all different components, as we can see this in the diagram. So these are different components. It's going to work with Google App Engine. In the next slide, we will see what are the features of this. So here, it is application resource. So what is the meaning of application resource here? See, these are different components you can find in the architecture of GAE. So here, this is a top level container within a Google Cloud project encompassing all the services, versions and instances that make your app engine application. So the application resource, nothing but it is a container. So it is a container. So it inside that you can find all the services and with the different versions and different virtual machines or instances for Google App Engine services or applications. Next one is services. So what is the meaning of services here? So it is composed of multiple services. So it is going to provide, means this GAE, it is a combination now, or is going to provide multiple services allowing for microservices based architecture. So it's also having architecture for microservices based. And each service can be configured independently with different runtimes and performance setting. So it's going to provide different services or multiple services, and all services are independent in nature, can be configured independently and also perform independently. That is the meaning of services. In the next slide, versions. So what is the meaning of version here? With each service, you can deploy multiple versions of your applications. This is the main concept here. So it is possible to have the same applications with multiple versions. And this enables easy rollbacks and testing and managing different development stages. So this is going to help for the developers for testing and deploying or developing different stages in software development. Next one is instances. What is the meaning of instances here? Though each version runs on one or more instances, which are automatically provisioned and scaled by App Engine based on applications load and configured scaling setting. So what is the meaning of instances here? So it is nothing but again a virtual machines. Through this is possible to have different snapshot. So the meaning here is the each version runs on one or more instances or one or more interfaces which are automatically provisioned. So here it's going to provide multiple instances for multiple services, and it is scaled by App Engine based on applications load and configured scaling settings. So based on the applications load from the user is going to configure the scaling. So nothing but it is auto scaling or automated services. So this is instances. This manages, means here talking about GAE. Here we see the components of Google App Engine. So here this GAE manages incoming requests from various clients and directs them to an appropriate App Engine services and instances, ensuring efficient load distribution and high availability. So this is GAE. The one of the component is going to make sure that the all services will be available to the user with high availability. I mean nothing but, as I told you in the previous slide, so it is nothing but fault tolerance. The users are able to access the services at any point of time round the clock. That is high availability. And ensuring efficient load distribution. So load distribution as far as the hardware is concerned, so it is nothing but load balancing. So any incoming request from the clients, different clients with different platform, and directs them to appropriate App Engine services. Here, any customers or many customers can go for different types of services from GAE. So this component is going to direct, by looking at the request, it directs the request to the appropriate services from this GAE. That is the function of this. Next one is front-end and back-end services. Let us see what are the definition of this. Here, this App Engine utilizes both front-end services like App Engine front-end for load balancing and static content servicing. So these are the example of front-end service. One is load balancing, that is traffic control, and static content servicing. These are the example of front-end services, and also back-end services for handling longer running tasks and processing data. So it's going to provide the services even at the front end as well as back end. So front end examples are services like load balancing. What is load balancing? So depending upon the request from the users or multiple users with different platform, is going to manage the traffic as well as the load on different hardware resources. That is the meaning of that. And next one is, if you look at backend services, is going to support or handle long-running tasks, suppose or processing the data. So you know what is processing the data is going to support the data for processing. Next one is long-running tasks. Some of the applications or the tasks, it may take longer time to execute the application to complete the task. During that time, the hardware resources will be busy. It is going to maintain or is going to handle these type of tasks. Next one is storage solution. So this is another type of solutions. What is the meaning of storage solution? So here, this GAE integrates with various Google Cloud storage options, including storage for static files, Cloud SQL for RDBMS, and data for NoSQL, and providing flexible data persistence options. So it is going to have integration, or it's going to work with different types of services from the Google Cloud. For example, it's going to provide cloud storage options. For example, cloud storage for static files, and SQL, cloud storage for SQL, as well as NoSQL data service for NoSQL databases. All these services can be integrated with the user's request and user's requirement. That is storage solution. Next component is task queue. So here, for asynchronous and long-running tasks, you know what we have seen in the previous slide. Example, sending emails, image processing, etc. These are the example for long-running tasks where it may take more time for processing. And App Engine utilizes task queues to manage and distribute these tasks to back-end servers, preventing front-end servers from being blocked. So what is the meaning of task queue? This GAE is going to maintain a queue. Is going to maintain a queue. So based on the request from the user, is going to have a queue. So based on that, is going to manage the request from the customers or from the clients. So it's going to transfer, or the request has been transferred to either back-end servers, so that is going to avoid the blocking of front-end servers. That is task queue. Next one is memcache, or we say memory cache. So here, a distributed memory caching service. This is a type of service available to App Engine for improving performance and reducing database load by caching frequently accessing data. So you know what the meaning of cache? You know, in general, what is the cache memory? So any files which are opened first, it will be loaded from the hard disk or from the server, and frequently if you keep accessing the file, those data or informations will be stored in the cache. And here we can make out the time difference between the opening a file first time and we are opening the file frequently. See, the same concept we are using here. There is memory cache, and this GAE is going to have this memory cache. The meaning is that, so here is going to, in improving the performance and reducing database load, nothing but to access the database information from the service. That is memcache or memory cache. Next one is runtimes. What is runtimes? This App Engine supports various popular programming languages like Python, Java, Node.js, and so on through its standard runtimes, and allow for customers runtimes using Docker containers for other languages and framework. So this is going to provide runtime for different types of high-level languages used by different types of customers. That is runtimes. Now let us move on to next concept, that is the Google App Engine application life cycle. It is nothing but how the applications are going to execute in GAE or from the Google App Engine. So here it has so many steps or so many stages here. So life cycle in cloud computing encompasses several key phases. As I told you, there are many phases or many stages from development to retirement. See, this is development to retirement in the sense for developing from the starting point to retirement to close this application to complete the task, and leveraging the platform as a service nature of App Engine. So it is going to provide this Google App Engine. It has so many phases or so many stages in completion the task from development to retirement. Now let us see, the first one is what is development and testing. So here the developers use App Engine software development kit. It is SDK. So here the developers use SDK of engine to build and test applications locally. So it is not exactly with the service providers resources, and along with that, if the any customers or the clients use it, if you're using the local hard disk or local resources, it can be run or test in their local resources. Now, this SDK, that is Software Development Kit, it provides tools for emulating the app engine environment, allowing for local testing and debugging before deployment. I mean, before deployment is nothing but implementing. Before implementing any of the applications, and these can be tested and debugging in their local environment. These applications are typically built using supported languages and framework. As we have seen in the previous slide, is going to support different types of languages and different types of framework. This is development and testing. Now, second one is deployment implementation. So once developed and tested, the application is deployed to Google App Engine environment. So this is the development and testing. It could happen in the locally with the customer's premises or with their local resources in the local server. And once everything is completed, after that, next one is deployment or implementing. It has to be loaded or deployed at the Google App Engine environment. It has to be loaded or implemented at the service provider's environment. So this involves creating an application identifier and uploading the application code and configuration files. So these are the steps to upload the application which has been developed into the Google App Engine environment. So deployment can be done through the Google Cloud Console and command line tools or even integrated development environment with App Engine plugins. So with the help of engine plugins, it is possible to deploy or implement the applications into GAE with different interfaces. These are different types of interfaces, or we can say plugin. Next one is management and operation. Next step is after development, App Engine handles the infrastructure, scaling and maintenance. Once the software is developed and deployed in the GAE environment, next one is management of these applications. It will be handled by Google App Engine. Developers can manage the application through the Google Cloud Console, which provides tools for monitoring performance, logs and resource usage. So even the users can manage the services with the help of different console or different interfaces, so that they can do different type of services, like they have different tools for monitoring the performance, network, the performance and also resources usage. Next one is this App Engine automatically scales instances up or down based on traffic to ensure optimal performance and cost efficiency. So this GAE is going to provide optimal services, or is going to provide the optimal performance by using the automatically scales up or down the instances. Next one is services and versions. As we have seen in the previous slides, it allows for managing different parts of applications and deploying new updates or rolling back to the previous version. So this is services and version. This is one of the phase. So it's going to maintain or is going to manage different types of applications or different stages of applications with different applications and different versions. That is services and versions. Next one is monitoring and maintenance. Continuous monitoring of applications health, performance and resource consumption is crucial. Generally, the service provider has to look into the concept of applications health and also performance and resource consumption. So this is they are going to monitor all these concepts through the GAE. This GAE is going to provide logging and monitoring tools to help identify and resolve issues. Any issues can be easily identified and it can be detected and it can be resolved through this GAE. Next one is security updates and bug fixes for runtime components are handled by Google, ensuring that underlying platform remains secure and stable. So as far as security is concerned, it's going to provide a security with respect to the applications in terms of debugging or in terms of updating the details, updating the software or resources without disturbing the infrastructure or without disturbing the underlying platform. That is monitoring and maintenance. In the next slide, we will see what are all different applications of this Google App Engine lifecycle. Next point is runtime lifecycle and support. So this App Engine runtimes are based on open source components and their support lifecycle is tied to the community maintenance of those components. So it's going to support these runtimes based on open source components. And this Google provides support for runtimes during their general availability and including security and bug fixes. So it's going to provide support, as we have seen in the previous slide about security, is going to provide support in different stages of the applications. Notifications are provided before runtime reaches its end of support phase and prompting users to upgrade to newer and supported runtimes. So it's going to provide notifications to the users with respect to the applications, whether it has reached the end of the application, whether the task has been completed. With respect to that, is going to get the notifications support at different stages of the application. Next one is retirement. That is optional here. So what is retirement here? If an application is no longer needed, it can be shut down or deleted from the App Engine. So this is the meaning of retirement here. If any application which has been developed and deployed in JAE environment, then it's working, they are working for some time. After some time, if the same application is no longer needed for the users and it can be deleted or shut down from the App Engine. That is the meaning of retirement. Next one is it involves disabling or deleting the application and its associated resources in the Google Cloud Console. So that is once any application is no longer needed by the user, it can be deleted. So what is the meaning of deleted? When it is the deleting, nothing but disabling not only applications along with the resources which are used by those type of resources or by the applications. This is retirement. Now we move on to next service, that is Microsoft Azure in industrial application. Now Microsoft Azure is a global cloud computing platform. It offers wide range of services including computing, storage, networking and AI to help the business build, deploy and managing applications. So as we have seen in the previous slide about GAE, Google App Engine, so it is Microsoft Azure is one of the product in computing, in cloud computing. So here it is a computing platform. It is a global computing platform. It's going to provide services like computing services, storage services, networking and AI-based services. It helps in business to build, implement and managing different types of application as per the requirement from the user. Now it provides infrastructure as a service, IaaS. So this Microsoft Azure is going to provide infrastructure as a service and is going to provide platform as a service and also software as a service. See, these are all different types of services in cloud computing. So this Microsoft Azure is going to provide all three types of services to the users and operating on pay-as-you-go model and allowing users to leverage Microsoft global network of data centers for scalability, security and flexibility. So this Microsoft Azure is going to provide services on demand or pay as you go basis. Means whenever the customers, the user would like to go for a service, and he can go for it once everything has been done, and he can he can take back the services from the service provider. So here the users are charged or is paying only for the time or amount of resources, charged for the amount of time he utilized the hardware or software resources from the service provider. So that is Microsoft Azure. Now look at the schematic diagram to indicate the Microsoft Azure network, and it has so many different components here. That is VNet, this AKS cluster, application server active node, Azure SQL, and it's also going to provide SQL for database services, and application server passive node. See, these are different components of in the architecture of Microsoft Azure. Now let us see what are all different components or services from this Azure. So one is cloud service. So it offers a comprehensive suite of services such as virtual machines, data storage, web app hosting, databases, analytics, and machine learning, and IoT. So this Azure is a cloud service, is going to provide these varieties of services to the user. Service models. And as Microsoft Azure is a cloud service provider and is going to support in three main service models, that is infrastructure as a service, and it is going to provide computing resources like virtual machines, storage, users to have common complete control over their environment. So first one is, as you know, infrastructure as a service. So it is nothing but the hardware part of it or infrastructure part of it. So with respect to IaaS, is going to provide the virtual machines as a service and storage service and also other computing services to the users. Next one is going to provide PaaS, platform as a service. As you know that platform as a service, so here is going to help the software developers to develop the applications as per their requirements, and also they can deploy their application, they can run the application, they can test the applications. So all these services are provided by Microsoft Azure. Next one is SaaS, software as a service. So it delivers fully functional software solutions over the internet. Say this Microsoft Azure provide these type of service models to the users. In the next slide, we will see what are the features of Microsoft Azure. First one is global infrastructure. What is the meaning of that? It manages a vast network of data centers worldwide. So that is the meaning of global infrastructure, and enabling business to deploy applications globally and efficiently. So here the meaning of global infrastructure is, and this they are going to provide, Microsoft Azure is going to provide the services to the users, to the global users, or any users can access these services and they can make use of applications and they can deploy the applications, everything globally. Next one is flexibility and scalability. It provides a flexible resource management and scalable options, allowing business to quickly adjust their computing resources to meet the demand. So the meaning is scalable and flexible. So scalable means any services of the service provider, it can be scaled up or scaled down as per the requirement or demand from the users. That is flexible and scalability. Next one is cost effective. See, the pay-as-you-go pricing model ensures that the customers are only billed for the resources they consume, helping to optimize the cost. What is the meaning of cost effective? Here, the users need not to invest much on the infrastructure part of it, because they are going to take the service from the service provider, and the service provider is going to provide the resources or the services only for the time they have used the resources, and also the type of resources they have used, and the amount of time they have utilized by the users, or they are going to bill only for those hours or those timings. That is pay as you go pricing. Support for open source technologies. So it is going to provide services for open and flexible platform and supports various programming languages and frameworks and open source technologies, providing users with choices for their development needs. So it's going to provide the variety of services to with the different types of platform to the users to meet their requirement. Next concept, that is Azure SQL database. This is another type of services provided by the Microsoft in the industries. Now, Azure SQL database as a platform as a service offering provides a managed, scalable, and highly available relation database services in the cloud. Its architecture is designed to abstract away the underlying infrastructure and from the users, allowing focus on applications development. So another type of service from the Microsoft Azure, that is Azure SQL database. So it's going to provide PaaS services, platform as a services. So the meaning is going to help the users to develop their applications with a different platform or any platform, and this they are going to provide different tools for managing these services or applications, and they're going to provide scalable and high available services to the users, and mainly they are dealing with relational database services. This Azure SQL databases is going to provide services for relational databases services. See, this is the schematic diagram, or we can say the architecture of this, and if you look into that, there are different layers we can see. One is the client layer. Here, server applications. These are our service applications. And next one is service layer. They are going to have a service layer. In the service layer, they are going to have different services like provisioning, billing, and metering, connection routing, provisioning, billing, and metering, connection routing. These are all the components in service layer. And if you look at the platform layer, so here we have SQL Server, Azure Fabric Management Services. See, there are three layers, and next at the bottom we have infrastructure layer. So if you look at the diagram, so this SQL database, and here see these are different components or layers of Azure, my Azure SQL database. Now let us see the definition of this. So what is the infrastructure layer? This layer comprises the physical hardware within the Microsoft data centers, including servers, storage, and networking. Obviously, infrastructure is nothing but the implementation or installation of physical hardware devices for the services. So this is going to provide, they will be having servers, storage devices, and networking with respect to hardwares. And the Azure Fabric Controller automatically manages this layer and ensuring that the resources allocation, load balancing, and fault tolerance. So this infrastructure layer, there we have Azure Fabric Controller. If you look at the diagram here, Azure Fabric Controller, this was the one. So this Fabric Controller, what is the function of that? Is going to automatically manage the services, and by ensuring the automatic resource allocation to the users and load balancing with respect to the trafficking and fault tolerance, means nothing but high availability. So all these are services maintained at the infrastructure layer. Next, platform layer. If you look at the platform layer, so it built upon infrastructure layer. This layer consists of SQL Server clusters and management services that oversees them. So obviously this platform layer is built on infrastructure layer. So if you look at the diagram here, See, this is a platform layer which is built on infrastructure layer. The fabric controller also manages this layer, handling tasks like provisioning, monitoring, and maintaining the SQL Server instances. So here the fabric controller is going to maintain additional services like provisioning, monitoring, and maintaining of SQL Server instances or virtual machines. Next, we will see what is a service layer. So this layer implements the core logic of the Azure SQL database services. It handles functionalities such as connection routing, provisioning new databases, billing, and ensuring high availability, and disaster recovery mechanisms are in place. So the main function of service layer is nothing but is going to take care of different functions such as connection routing. So it is going to the connection routing in the sense different parts of communication, and provisioning new databases. Is going to add or is a chances of adding new more database services to the existing infrastructure. This is to look for the customer's details for their resources and applications with respect to their billing, and ensuring high availability is nothing but the fault tolerance, and it makes sure that the users or the clients must get the services round the clock at any point of time. Next, disaster recovery, another function of this layer. This layer manages the life cycle of the databases and provide interfaces for users to interact with the services. So it's going to maintain the life cycle of the databases. The life cycle in the sense when the applications, when you start developing, deployment, implementing, and usage by the customers using different types of applications, everything will be taken care of by this at different stages with respect to applications or consent, and is going to provide interfaces for the user so that they can directly interact with the services. That is service layer. We have seen the client layer at the top. So this is outermost layer, and where the client applications and services are reside. See what you have seen in the diagram. See, this is the client layer where we can see the applications so that the users can access the services through this layer. And these applications, whether non-premises or hosted within the Azure, connect to and interact with the Azure SQL databases instances through the service layer. So whether the applications is on the premises or in the Azure environment, but is going to connect with the Azure SQL database. Next slide. Now let us see what are all the different features of architecture features of this Azure SQL. So first one is managed services. So it handles aspect of infrastructure and platform management, including patching, backups, upgrades, and reducing operation overhead for the user. So it's going to manage the services like upgrading the software, versions of it, taking backups, and patching the software, all these things, so without burdening the users. Scalability means at any point of time, it can be scaled up or it can be scaled down. Now, high availability means fault tolerance. The users can access the services at any point of time. Next one is multi-tenancy, means this architecture supports multiple tenants, means multiple users applications sharing the same underlying infrastructure while maintaining isolation and security. So it's going to provide or support multiple applications of the users or multiple users with the same applications. That's the concept of multi-tenancy. Next one is integration. So what is integration? It is seamless integration with other Azure services like Azure Data Factory and Azure Machine Learning, and building comprehensive cloud solutions. So this Azure SQL service is going to integrate with other services of Microsoft Azure. Students, so far in session, we have covered the different service providers with respect to cloud computing in industry. Let us continue our discussion in my next class. Thank you so much.